Think about it. You use a computer every single day. We click, we type, we tap on screens, and things just happen. But have you ever really stopped to wonder how that works? How does your simple action tell this complex machine of circuits and silicon what you want it to do?
All right, so let's break this down. Over here, you've got us, the user. And way over on the other side, you have the raw computer hardware, the processors, the memory, the chips. These two things, well, they speak completely different languages, so what bridges that massive gap?
And that right there, that's the big question, isn't it? How does this incredibly complex machine understand our pretty simple requests? The answer is the key to pretty much all of modern computing, and it's what we're going to unpack right now.
To solve this puzzle, we've got to introduce you to the computer's invisible boss, the single piece of software that makes everything else possible. That bridge, that translator, that manager is the operating system. It's probably the most important piece of software on your computer, and it's working silently, tirelessly, every single second your device is on.
Okay, so we've thrown the term around a bit. Let's get down to brass tacks. What is an operating system, or OS, as you'll usually hear it called?
You know, the official definition is actually pretty perfect and simple. It's an intermediary, a go-between. It's the thing that lets you, the user, communicate with the guts of your computer without needing to know a single thing about how they actually work. So, the OS is constantly juggling a few really important goals. For you, its job is to make the computer convenient and to run your programs without a fuss. But from the computer's perspective, the goal is pure efficiency, squeezing every last drop of performance out of that hardware. I love this slide because it gets the idea across so well. Think of the OS like the conductor of a massive, complex orchestra. It allocates resources, telling each part what to do, it monitors all the activities to make sure they're working in harmony, and it manages all your data, keeping everything organized.
And this quote really boils it down to two core jobs. First, it's a resource allocator. That just means it decides who gets what and when, which app gets to use the processor, which file gets saved to the hard drive. Second, it's a control program. It keeps an eye on all your apps to prevent errors and makes sure one rogue program doesn't crash the whole system.
Okay, to really get where the OS fits in, it helps to picture a computer system like a stack with different layers. So let's peel them back and see how it's all put together.
It's a stack, and each layer relies completely on the one below it. You can't have the top without the bottom. Let's take a look at the blueprint.
So check this out. This diagram lays it all out perfectly. At the very bottom, the foundation, you have the physical hardware. Sitting directly on top of all that metal is the operating system. Then come your applications, your browser, your games. And way up at the top, that's us. The OS is that critical foundation for everything we actually do on a computer.
Now let's go one level deeper. Right at the very heart of the operating system, you'll find a component called the kernel. This is the absolute core, the engine room. It's the one program that starts up the second you turn your computer on and only stops when you shut it down.
And this image here shows exactly where it lives. The kernel is the ultimate middleman, sitting right between your applications and the physical hardware, the CPU, the memory, all of it. It's the part of the OS that speaks directly to the machine. All right, so we know what it is and we know where it lives. Now let's see how it actually gets the job done, starting from the very moment you press that power button.
You know, every time you start your computer, this amazing little chain reaction happens. First, you hit the power. A tiny program called the BIOS wakes up. Its only job is to find a device to boot from, like your hard drive. Once it finds it, it loads another small program called the bootloader, and that program has the most important job of all, loading the OS kernel into memory. As soon as that's done, boom, the OS takes complete control.
And this flowchart is basically the map of that journey we just described. It's this beautiful handoff from one small program to the next, all culminating in the kernel taking the helm and running the whole show. Okay, so the OS is up and running, but think about it. Thousands of things are happening every single second. Your mouse is moving, you're pressing keys, a file is downloading. How does it manage all that chaos? Well, it does it with a constant stream of signals.
These signals are called interrupts. The best way to think about an interrupt is like someone tapping the processor on the shoulder and saying, "Hey, excuse me, I need your attention right now." It could be your keyboard saying a key was just pressed, or your network card saying new data has just arrived.
And this diagram shows exactly what happens during one of these interrupts. A program is just running along in user mode. Then an event happens, sending an interrupt signal. Instantly, the OS pauses that program, switches into the super powerful kernel mode, figures out what the signal was for, handles it, and then seamlessly resumes the program right where it left off. This happens thousands of times a second.
All right, let's pull back from the nitty-gritty for a second. We've been deep in the technical details, but what's the big picture here? Why is this fundamental piece of software so incredibly important?
Well, the answer is pretty simple, because the operating system is quite literally everywhere. The smartphone in your pocket, the laptop on your desk, your smart TV, maybe even your car, they all run on an operating system. It is the invisible software that powers our entire modern digital world. And it doesn't matter if you're a fan of Apple, Google's Android, or the open source world of Linux. Every time you use one of these devices, you are interacting with a highly sophisticated operating system. They make the ridiculously complex feel simple, and the impossible feel possible.
So I want to leave you with this final thought. The OS was perfected in an era of one person, one computer. But our world today is all about interconnected devices, our phones, watches, cars, homes. This raises a really fascinating question. What will the operating system of the future look like? What will it need to do to manage not just a single device, but an entire ecosystem of them, all working together seamlessly?